back everybody. I am a teacher from Ilm Online Academy. In today's video, the topic is Petrochemicals and Polymers. This is basically chapter number 20 of the ongoing series for the Cambridge Chemistry 0620, and in today's video, we'll be having a look at the petrochemicals and polymers. Without further ado, let's just begin and let's first discuss the contents which we will discuss in today's video. So the contents which are included in this chapter, first we talk about the petroleum and its products. Second, we talk about the polymers, and in the last we will talk about the plastics. So these are the three contents which are included in chapter number 20 of petrochemicals and polymers. So first we will talk about the petrochemicals, petrochemical products and petroleum, and next we will move towards the polymers. So you can see here we have petrochemicals that are present there, and the petrochemicals and their products mostly includes the fossil fuels, which we know that, and these fossil fuels are used for the energy mostly. Fossil fuels were formed in the earth crust from the material that was once living, like from the living organisms. When they died, they buried under the soil, and many layers of the soil are present on that, and after so many millions of years ago, their bodies are converted into the fossil fuels. So fossil fuels, or you can say that the petroleum or the crude oil, you can also call it as petroleum, which are the petrochemicals, or there is another name for the petroleum, that is the crude oil. Crude oil comes from the underground or from the earth crust, and this is a fossil fuel that is formed over millions of years ago by the conditions of high pressure and high temperature. High pressure is given by the layers of the earth that are present on them, and as we know that the core of the earth has so much high temperature as compared to the surface. So just because of that, as it is more nearer to the core, so that's why high temperature is also provided there, and though these conditions act on the remains of the dead sea creatures, living organisms, plants, bodies of the living organisms, and also the dead bodies of the plants, so they convert into the fossil fuels, which are known as the petroleum or the crude oil. These fossil fuels are the source of energy. They provide us energy. They are the sources of energy that we use for running industries, for running cars, or for anything which we are doing that. For that purpose, we are using this energy sources. And these energy sources, which we are talking about, fossil fuels, and some other sources of energy are also included this, and they are formed in the earth over millions of years ago, and which we are now using up at a rapid rate, and they cannot be replaced. So they cannot be replaced. We also call it as renewable energy sources, non-renewable energy sources, and you also call it as the finite resources. Finite or non-renewable energy sources. So these are the energy sources that are used faster. They are used faster and they cannot be replaced. They are present in limited quantity and they are used faster and they cannot be replaced. These are known as the non-renewable energy sources and finite resources, cannot be replaced. So that's why you call it as the non-renewable and the finite energy sources. They are used faster and used up faster, and they cannot be replaced. They are depleted much more easily, and these include examples of these fossil fuels which are considered as non-renewable. We have coal, oil, and we have the natural gas. These are the most common examples of these fuels. So coal, oil and natural gas, these are the fossil fuels that are formed underground over geological periods of the time from the remains of the plants and the animals. That's why you call it as the non-renewable and the finite resources. So if we talk about some renewable resources, just for the difference, renewable energy sources are, you can say that they are practically infinite and they cannot be depleted. And the examples of these renewable energy resources are, we have wind, we have solar energy. These are the examples of the renewable. You can also call it as the infinite energy sources because they cannot be depleted so much easily. They will not run out eventually. They are present for a longer period of time. So that's why we have the examples which are solar energy and wind. These are the renewable energy sources. And non-renewable that are present in limited quantity and they will run out eventually, which are known as non-renewable and the finite resources. And in that example we have fossil fuels like coal, oil and natural gas. So if we separately talk about coal, we have coal. Coal is a black solid fossil fuel. This is the black and present in the solid form that is formed underground over a geological period of time by the conditions of high pressure and high temperature that act on the decayed vegetation. By the decayed vegetation, it forms the coal. Vegetation that includes plants, plant bodies, trunks, all are included in this one, and that formed into the fossil fuel that is known as coal. And if we talk about next, we have natural gas. Coal is a solid, but natural gas is in the gaseous state, and this is a fossil fuels that is formed over a period of time by the conditions of high pressure and temperature that act or remains of the dead sea creatures. By the remains of the dead sea creatures. So natural gas is more than 90% reliable. It is in the form of methane that we are using in our mostly for the cooking purposes. We are using the methane gas in our stove. So natural gas is 90% or mostly methane. And in the last we have coal, we have oil. Oil is basically the petroleum or the crude oil that we talked about the earlier. This petroleum or crude oil that comes here, it has so many fractions, and you have to, like, you can say that this crude oil is a mixture of so many products, so you have to separate them by using special process that is known as fractional distillation, and by that you have the fractions of the different liquids that are used to separate them based upon their different boiling points. We will also talk about this one in this, the fractional distillation, through which you are using for the petroleum and the crude oil. Now we'll talk about the formation of the petroleum. So petroleum is one of the Earth's major natural resources, and this is a result of a process that began up to 400 million years ago. So when marine creatures died, they sank to the seabed and they were covered by the mud. You can see here, this is the dead and the decaying matter. So for the petroleum or the crude oil that forms, this is basically due to the marine or the marine dead creatures. They sank to the seabed and were covered by the mud. You can see here, these are the sedimentary rocks. Sedimentary rocks are these are basically the layers that are present, and you can see there that the layers of the salts were covered by the mud, and they change into the petroleum and the natural gas just because of these sedimentary rocks. And you can see here there are layers, so layers of muds are present there. So just because of these layers, a high pressure and high temperature was brought due to this one, and then high temperature and high pressure and conditions are available, and bacteria act over the millions of years ago. So the original organic material was broken down into the hydrocarbons. So we have some geological movements also and pressure that are created. We have reservoirs of oil and gas. So these reservoirs are not lakes of oil or packets pockets of the gas. Instead, the oil or gas is spread throughout the pores in the coarse rocks such as the sandstone or the limestone in much the same way as the water is held in the sponges. So once a field is established, the production of oil rigs can be set or on land at the sea. Like here you can see this one at this place we have the oil rigs that are present there. So these oil rigs in some sea or wherever the petroleum and the crude oil is present, they are set up on the land or at the sea. So we have now, you can easily get the petroleum that is formed under the layers of mud. So first what will happen, we have some steps that are involved. The first step is the organic remains settle. The remains of the plant, algae, bacteria, and most of them the marine dead creatures that are present there, they settle down to the ocean floor whenever they died, and they mix them with the sand and the silt that is present. So over the time passes, the remains are buried under the layers of sand. Layers are present here, like you can see here we have first layer, second, third, fourth. So many layers are present on the top of them. And then what will happen, due to these sedimentary rocks and the layers that are present there, the weight of these above the remains increases the pressure and also the temperature, as they are more nearer to the core of the earth, and the core of the earth has much higher temperature as compared to the surface. So that's why high temperature is also given at that place. And then organic matter decomposes by the bacteria that are present in the soil, and they are decomposed into the carbon rich substances that are present there. So then it is transformed into the petroleum. That is the substance that transformed into the petroleum and the natural gas through a process which is known as cracking. We will also talk about the catalytic cracking or the cracking that happens here. In our previous chapter we talk about the catalytic cracking also, like in chapter number 17, you can also that one. And in the last, what will happen, the petroleum rises because it is less dense than the surrounding rocks that are present there, and petroleum is mostly that is present there in the liquid state. So just because of the liquid state, the rocks are solid and the petroleum is in liquid, so it rises up and it is less dense. So that's why you can easily get the petroleum from the layers of the mud or the soil that are present in our earth crust. So this is how you can get, or this is the formation of the petroleum that forms over millions of years ago under the earth crust. Now next, after getting this petroleum or after mining them, we will next talk about the how you can extract or how you can separate out the fractions of the petroleum that are present in them, and that is by the process which is known as fractional distillation of the petroleum. So we have fractional distillation of the petroleum. And petroleum is basically this is a mixture of so many hydrocarbons that are present in them. Hydrocarbons are those that contains carbon and hydrogen in their compounds. So the mixture of different hydrocarbon molecules is known as a petroleum, and most of the petroleum that is extracted from the ground is used to make the fuel, but around 10% is used as a chemical feedstock. Chemical feedstock is basically, you can say that, the raw material for an industrial process making so many useful chemical products. So before the petroleum can be used, we have the various hydrocarbon molecules are separated by this process which is refining, and you can also say it as the fractional distillation. So refining and fractional distillation, these are the two processes through which you can separate out the fractions that are present in the petroleum, and that this will act at the oil refinery. So this fractional distillation is a method of distillation using fractionating column, and this is used to separate the liquids, for the separation of the liquids that are present in the mixture of the petroleum. And this is basically based upon their different boiling points. Boiling points are much important, and this will done on the boiling point ranges of all the hydrocarbons that are present in them. You can see here on my right we have various petrochemical fractions, and in these petrochemical fractions we have the name of the fractions. Like first one is the refinery gas, second one is the gasoline, and you can also call it as the petrol that we got from the extraction of the or separation of the petroleum. Next we have naphtha, kerosene or paraffin. Kerosene is basically used for the fuel for the aircraft. Next we have diesel oil or gas oil. Next fuel oil we have, and next greases and waxing. These are also the lubricating fractions that we come from. And in the last we have the bitumen, and bitumen is basically used for the road surfacing. So we have the number of carbon atoms that are present in them and the boiling points, and based upon these boiling points, first of all we provide the temperature, and slowly increases the temperature. Whenever the temperature move up to 30 or 25 degrees Celsius, the refinery gas that is present in them will convert into the gaseous state, and when it converts in the gaseous state, it is collected by the separating column that is present on them. So you can separate out or extract out by this one. Next, whenever the temperature reaches to 100 or 150 degrees Celsius, the petroleum that is present in the mixture will convert from the liquid to the gaseous state, and then we will also collect this one from in a separate container. So this is how fractional distillation is done at the oil refinery, and these are the approximate number of the carbon atoms in the hydrocarbons that are present in them. And next one we have the approximate boiling point ranges through which you can separate out or through which we do the fractional distillation. So in a refinery, this is the fractionating tower, or you can say that the fractionation of the petroleum will happen. So at the refinery, petroleum is separated into the different groups of hydrocarbons that have different boiling points, as you can see here in this table. So they are separated based upon their boiling points that are roughly related to the number of carbon atoms on the chain length. As the number of carbon atom increases from top to the down, you can see here number of carbon atom increases from top to the down, and then the boiling point also increases because of increase in the chain length. So here we have the different chain length that represent different hydrocarbons, and the separation of the hydrocarbons take place by the fractional distillation using a fractionating column or fractionating tower. At the start of the refinery process, petroleum is preheated at a temperature here by the heater. Petroleum is preheated at the temperature of 350 degree to 400 degree Celsius. This is the preheat temperature, and then it is pumped at the base of the tower. You can see here the crude oil is entered into the base of the fractionating tower, and as it boils, the vapor passes up the tower, and it passes through a series of bubble caps and cools as it rises further up to the column. Like you can see here, refinery gas, which has the temperature of which has a boiling point of roughly or approximately 25 to 30 degrees Celsius. So first the refinery gas will move or will rises up, and then it is separated through a separate column. This is a column through which the refinery gas is separated, and then it is cooled. So the different fractions cool and condense at different temperatures, and therefore at the different heights in the column. The fractions condensing at different levels are collected on the trays. Here we have some trays for the separation and for the collection of these fractions. And fractions from the top of the tower are called the light, and those are present at the bottom, they are heavy. If we talk about the state, the refinery gas is the only one that is present in the gaseous state, and gases are light in weight. So the fractions on the top, like we can say that petrol, naphtha, up to the kerosene oil, like mainly these are present in the liquid state, and the fraction that are present in at the bottom of the tower, they are heavy. And residue, or you can say that the bitumen, this is the most heavy one which is present here. So each fraction contains a number of different hydrocarbons. The individual single hydrocarbon can then be obtained by further distillation process. And in this figure you can see here we have the separation into the different fractions, and also some of their uses are also present there. Like whenever the temperature reaches up to the approximately 70 degrees Celsius, then petrol is collected, and then it is cooled to convert it into the liquid state, and this petrol is used as a gasoline, which is used in the fuel in the cars. Next we have naphtha. Naphtha is used as a chemical feedstock, mostly used as a raw material for the production. This naphtha mostly used for the production in the industrial processes to make any products. Next we have diesel oil, that is used in a fuel in the diesel engines. We have also kerosene oil. Kerosene oil is mainly used for the aircraft fuel. Next we have fuel oil, which is used in the ships and also in the home heating purposes. And in the last we have the lubricating oil and also the residue. So lubricating oil is used in waxes and in polishes, and also in other machines. And residue is basically, you can say that this is the black residue that is present there, and this is usually used for the surfacing of the roads, and this is the black residue that we collected from the bottom of this fractionating tower, means bitumen is present here. It is so much heavy, this is so much dense, so you have to collect it from the fractionating tower or fractionating column like this. So this is how the catalytic or you can say that the fractional distillation of the petroleum happens at the refinery. At the oil refinery we have separate industries that this would happen there, and at the oil refinery we have fractionating tower, and you have a system of providing the heat. So whenever you provide the heat, the fractions are converted into the liquid state, and then they are from liquid they are converted into the gaseous state, from where we have separate columns that based upon their boiling points we collect them. So this is how the fractional distillation of the petroleum happens in our industries. Next, the second method through which the distillation of the petroleum happens, that is the catalytic cracking. We'll talk about now that one. So now we'll talk about the catalytic cracking. So all the fractions that are obtained from the distillation of the petroleum that we have done before, they are useful, and some are more useful than the others. So there is a greater demand for those fractions that are much useful, like the demand for the various fractions from the refinery does not necessarily match with their supply from the oil, but the petroleum from the different oil fields varies in composition. So the values that are present there, like you can see that the differences in the supply and demand for the refinery fractions. This is the graph. You can see here there's a difference in the supply and demand for the refinery fractions, and the petroleum from different oil fields varies in composition. So the values that are shown here in this graph, they are variable, but the general trend is also true. The green one you can see here, this is the demand from the customers. They basically demand more for the gasoline, which is the petrol, and the naphtha. So the lighter ones are, you can say that some are in more demand, like the petrol, which is the gasoline, which is also known as the gasoline, the green one, and the supply from the refinery is less. So here if I talk about the petrol, this is more in demand, and there is greater demand for the lighter fractions like petrol that have shorter chain length. Petrol have shorter chain length, carbon chain length that we talk about, and the opposite is true for the heavier fractions like the paraffin and the diesel. You can see here the demand is less as compared to the petrol and the other things. So next, the longer molecules from these heavy fractions can be broken into the shorter one to make it valuable one. So this is how the cracking is done. Cracking is basically the catalytic cracking, or also as the cat cracking, in which we have hydrocarbons, and hydrocarbons are all the hydrocarbons, like mostly the longer molecules from the heavier fractions, they are broken down into the shorter ones. Like the longer ones are converted into the shorter ones by the use of catalyst. So all the cracking reactions, we have the alkane with a shorter chains than the original, and a shorter chain alkene, and two or more alkenes and hydrocarbons. So cracking is the process by which the heavy hydrocarbon molecules are converted or broken down into the lighter ones by the use of pressure, by the use of catalyst, or we can say that these conditions are used in the cracking to convert the longer or the heavier one into the shorter chains, or you can say that the lighter ones. So whenever the catalytic cracking reactions happen, they give us alkane, shorter chain than the original ones, or and short chain alkenes, and two or more alkenes and hydrogen is also released in the catalytic reactions, or we can say that the cracking reactions. So the equation for this one, like if we talk about the example how the catalytic cracking happens here, we have, for example, we have a longer chain alkane like which is C10H22, which is known as decane. So whenever the cracking happens on the decane molecule, it is converted into the pentane, which is C5 and H12, plus we have propene, which is C3H6, plus we have ethene, which is C2 and H4. So decane, which is the alkane, when the catalytic cracking happens on them, it is converted into the pentane, which is the alkane, and it is shorter in chain than the original one, and plus we have two alkenes, like the first one is the propene and the second one is the ethene. So you can see here the first one of this, that is saying whenever these reactions happen, we have alkane of shorter length, this is which is the pentane that we have, and next we have short chain alkenes that are produced like propene and the ethene, shorter chain than the original one. So this is how the catalytic cracking reactions happen. And the second one, maybe in the products we have two or more alkenes and also the hydrogen atoms, like another example, suppose we have butane, which has a formula C4H10. Whenever the cracking happens on them in the presence of a catalyst, they are converted into the alkenes like C4 and H8, which is the butane, plus we have hydrogen gas that is produced. So this is about the second one. So whenever cracking happens, we have these two situations. We have alkanes, then the shorter chain than the original one, and also alkenes, and in the second one we have two or more alkenes and also the hydrogen atoms. So this is how the cracking happens here, and we have several different reactions that can take place during the cracking, and the mixture of the products can be separated by the fractional distillation. All the products are useful. The short chain or the shortened alkanes can be blended with the petrol fraction to enrich the petrol, like we have so many useful, like alkenes are useful as a raw materials for making many or several important products, including the polymers and something like that. So this is how the fractional distillation of the petroleum happens, and also the catalytic cracking happens in our industries. So now we'll move towards the next content of our chapter, which is basically the polymers. The polymers. The simple definition of the polymer is all the living things contain the polymers. All the living things that are present there, they have polymers. All living organisms, or you can say that the all living things contain the polymers, which are maybe in the form of proteins, carbohydrates, wood, natural rubber. So all these are the polymers. The basic definition or the simple definition of the polymer is this is the class of, you can say that, the natural or synthetic substances that are composed of very large molecules that are made by polymerizing a large number of repeating units, which are known as monomers. So whenever monomers attach them, then we have the polymers, and the process through which the polymers join together, this is known as polymerization. So the polymers make up many of the materials in the living organisms, like we have the larger molecules like the proteins in our bodies, and proteins are made up of the smaller ones, which are the amino acids. Amino acids are the monomers that attach together and form a large molecule that is known as proteins. So polymers of amino acids formed by condensation reactions, and they have a wide variety of biological functions. This is the polymerization process that you can see here. We have so many monomers that are present there. So whenever monomers attach together, or they form a bond is present, whenever they create a bond between them, they form the polymers. Poly means many, so when many monomers attach together, they form a polymers. And mono means one, that means this one molecule is known as monomers, and whenever they attach with each other, they are known as polymers. So a monomer is a small molecule that can be such as ethene, which can be polymerized to make a polymer. Poly means many. Poly means many, and mono means one. So polymerization, this is the chemical reaction in which the monomers join together to form a long chain, which is known as polymers. So long chains are present in them, which are known as polymers. And as we are talking about the polymers that are present in our human bodies, like proteins, carbohydrates, and other than that, in our nature we have wood, natural rubber, all these are the polymers. If we talk about the synthetic polymers or the synthetic substances, which are also the plastics are also made up of the monomers, and they are found everywhere in our modern technological societies, ranging from the car, aircraft components to the packaging, and also clothing, toys. So all these are the synthetic ones. And polymers are the large molecules that are made up of the repeating units, which we call as the monomers, right? So this is about the polymers and the polymerization. Next, if we talk about, we have different types of the polymers, like based upon, the first one is homopolymer. Homopolymer, as the word suggests, that homo means same, right? So some polymers are homopolymers containing just one monomer is present in them. Like one type, you can say that one type is present in them, one type of monomers, like polyethylene, we have polypropene, we have polychloroethene. All these are the examples of the homopolymers. Next, we have copolymers. And in these copolymers, we have these are made up of two or more different types of monomers. In the homo in which just one type of monomer is present, and in the copolymers we have two or more different types of monomers are present, like nylon. The example of this one is nylon, and nylon is made up of two monomers and biological proteins. Like for example, we have that are present in our body. They are made up from 20 different monomers, like that 20 amino acids. 20 different amino acids attached together, and then they form the proteins. So this is how the polymers, and we have different types of polymers, and we also talk about related to the monomers and the polymerization. Next, we will talk about some reactions that happen in them, in the polymers. The first type is the addition polymerization that happens here, and the second, we also talk about condensation polymerization. So these are the two reactions that happen in them. So first we will talk about the addition polymerization. So first of all, the definition of the addition polymerization. Addition polymerization, or which is also known as the chain polymerization, this is a chemical process that happens here, and in this we have so many monomers that are attached together. Monomers are attached together to form or to make a polymer. So that is known as the addition polymerization. So on my screen you can see here we have the example. The alkene fragments from the catalytic cracking of the petroleum fractions produce the starting materials, which are the monomers. So these are the monomers, or you can see that we have alkene molecules that are present there that act as a monomer for the starting monomers for the plastics. So alkenes, which have double bond that is present in them, as you can see here, these molecules can take part in these reactions where the double bond is broken and the other atoms attached to the carbon atoms. The addition reaction we also talk about in the chapter number 19. Whenever bromine is added into the alkenes or the alkynes, double bond or the triple bond will break, and then they form the alkanes. That is also the addition reactions. So the double bond in the alkene or ethene enables many molecules of ethene to join together to form a large molecule, which is known as polyethylene. Polyethylene is, as we have done there in the previous, this is the homopolymer in which just one type of monomers are attached or together, and here you can see, here you can use n number of molecules in this, like this one, these dot represents also the n, means so many different molecules can attach here in this chain to form the addition polymerization or the polymer. So when you draw a section of the polymer chain, you must show the open continuation bonds at the end of the section. This one, this is why, just because of that, this is a very large number, so different number of molecules can attach there to form a polyethylene. So we have monomers, which is the double bond that is present in them, and these monomers, or you can say that the double bonds that are present in them will break apart, and when the double bond breaks, then the you can say that the second monomer that is present there will attach with the first one. So this is the carbon-carbon chain length creates in them. And now in the last we have the polymer, that is the polyethylene, and this one here you can see here, this is there is a space, and other molecules will also attach there. So we have some conditions that can be used to produce different types of polyethylene. Generally high pressure and temperature or above the room temperature and a catalyst are also needed, and the reaction that is present here, you can see this one. So if we talk about just the simple word equation, like ethene is converted into the polyethylene or the polymer, then you have to provide the high pressure is given, and with the high pressure we also have to give the heat or the temperature, and a catalyst is also used in this process. This reaction happens above the room temperature. So this is the polymerization of ethene. A large number of monomers are joined together here, and this continuation represents the n, that is the large number of molecules can be attached there. So polyethylene can be found to be a chemically resistant material that was very tough and durable and is used in so many plastics. So this is also a very good insulators. We have also some other alkene molecules can also produce addition reactions, like in which we have double bonds are present. Addition reactions are always given by the unsaturated hydrocarbons which have double or triple bonds. Addition reactions are not given by the alkanes, which are the saturated hydrocarbons. So if we talk about the propane, like in which we have 3 carbon atoms are present there, like this one. So the major or the most important one is the double bond. So this is the monomer that is used, and n number of monomers are attached together. The double bond will break. Whenever the double bond breaks, next we have carbon-carbon. So you have to show this line that shows that any molecule can be attached on both sides, because now the double bond is broken down here. Whenever the double bond breaks, then you can attach so many different molecules. So this is how the polymerization, or you can say that the addition reactions happen, and the n will be present also at this stage. So that represents that we have so many molecules of the this is the polypropane that is formed here, or this is the polymerization of the polypropane. So this is how the polymerization happens here, and all these equations summarize the polymers that we have read about. So in the discussion, there are different ways to represent formation and destruction of the addition polymer. And if we talk about some monomers and more about the polymers, like if we talk about from monomer to polymer, like some differences from monomer to polymer. And we also talk about the opposite to this one. So from monomer to polymer, first we have to draw the monomers with their double bonds next to each other, like which we have done with the ethene, like suppose here, and then remove the double bonds and draw the single bonds in the space between the monomers. So these are the monomers that are present there, and then whenever you show the polymer, suppose this is the monomer, and you can take n number of, after that you have to draw the single bonds that are present in these carbon atoms, like this one. So this is the polymer. and hydrogen atom are also present there. You have to add hydrogen atoms here just to complete the valency of the carbon atom. So this is how the monomer from the polymers are made. And if we talk about the opposite, from polymer to monomer, that means now you are removing the units or the monomer that are present in the polymer. So first you have to identify the repeating unit that is present in them, that will have two carbon atoms with a single bond between them, and just put a bracket in them. Like for example, in this one, in the upper one, we have the repeating unit here with the double bond, not the single carbon. You have to add that double bond. Take it, right? So you have to check this one, draw the that unit as a separate molecule with a double bond in it. Like if we draw this one, carbon carbon double bond, and then we have two hydrogen atoms with one carbon and two hydrogen atoms with the other. So this is the polymer. So from the chain or from the polymer, you first have to identify the monomer which have double bond that is present in them. So this is how you can do this, or how to deduce the relationship between the monomer and also the addition polymerization or the addition polymers. We have in our book, we have so many polymers with their monomers that are present there, and also their properties and examples of them you can also check from that one. And some synthetic polymers like plastics, polypropylene, and they are easy to shape by melting and molding. So therefore they can be used to make plastic objects such as crates, and also to draw into long fibers for making ropes. And so you can use it at so many different reaction. So this is how the addition polymerization happen. In addition polymerization, if we summarize this one, this is just the polymer is formed by an addition reaction. The monomer molecules that contain a carbon-carbon double bond, or the unsaturated ones that are attached together, double bond is broken down between them, and then the polymers are formed. So this is how the addition polymerization happens, and this is the summary of this one. First we have long chain molecules, and then double bond breaks, and in the last we have the polymers that are formed. Next reaction is the condensation polymerization. So the simplest definition for the condensation polymerization or reactions, this is just a chemical reaction where the two or more substances combine together to form a larger compound, and a small molecule is usually given off, and that is the byproduct. That is mostly, in most cases, we have the water molecule. So this is formed when a condensation reactions happen or takes place between the monomers to join together in the polymer chain. In the addition reactions, just monomers link together, attach together, and there is no byproduct, or you can say that no molecule is given off in that one. So that's why there is a big difference between these one. So for the condensation reactions, we will talk about the polyamides and the polyesters. So first, if we talk about the polyamides, poly means many, and you can see here this is the polymer where the monomer units are joined together by the amide one. The amide, or you can say that the peptide, amide represents the peptide links, or you can say that the peptide units, like we have nylon and we have also the proteins. Peptide links or peptide units, so these are the polypeptide. Amide refers to the peptide links, for example nylon and the proteins. And the next example which we discuss in this are the polyesters. We also talk about the polyesters in our organic chemistry. So this is a polymer where the monomer units are joined together by the ester links. There is a ester linkage or ester link that is present there, and the example of this one is P, E and T. This we will talk about this one here in the example of these condensation reactions. First we have polyamide. This is a reaction between the carboxylic acid. We have a carboxylic acid which have carbon-carbon double bond and hydroxyl group, and with that we have the other chain length that is present, and also a molecule and the next one is, you can say that we have a molecule that contain the amine group, and that may be any amine like nitrogen, in which hydrogen is present, and this is the amine, and this one is the acid or carboxylic acid, and this one is the amine. So whenever the reaction between them happens, what will happen here? That produces a compound that is known as amide, and with that we have a byproduct that is water. How water is produced? Hydroxyl group is removed from the carboxylic acid and hydrogen is removed from the amine group, and then they will produce the amide linkage or amide, that is carbon-carbon double bond. Nitrogen is attached, this bond of nitrogen is attached with the carbon, and then we have like this. So this is the amide linkage that is formed by the removal, or you can say that by the elimination of a small molecule, that is water. Water is just a byproduct, so forming a amide linkage, this one is happening here. And next, if we talk about polyesters, so polyamides reaction happens between the carboxylic acids and the amino group, or any amine, you can say that. Okay, you can take any amine here. And next, if we talk about the polyesters, in case of polyesters in which ester link is established, that is formed between the carboxylic acid, like carbon-carbon double bond, and hydroxyl group is also attached, and here this bond shows that the one on the left means any carbon chain, you can take any carboxylic acid. So plus we have alcohol that will attach here, means that have hydroxyl group like this, and with the like you can take here methanol, ethanol, propanol. So with this bond, any number of carbon atoms can be attached there. So you have to take the carboxylic acid and the alcohol. With this reaction, hydroxyl group from the carboxylic acid and hydrogen is removed from the alcohols to form the polyesters. Water is eliminated, or water is produced as a byproduct, and then they will form the ester, which is carbon-carbon double bond with the oxygen that is present here. So on the both sides we have bonds, and any number of carbon atoms can be attached there to form a polyester. So this is how the ester is formed by the elimination of a small group, which is known as the water. So the reaction between the alcohol and the carboxylic acid, which is the esterification, that forms the ester, and the link between the two parts of a ester molecule is an ester link. The link between these two particles, that is known as the ester link, that is formed when water is removed from these one. So the polymerization of a large number of appropriate monomers using one or other of these condensation reactions produces a polyamide or polyester respectively. So this is how they produce. So this is about this one. And next we will talk about the nylon, which is a polyamide, the specific example in this, and also in the last we also talk about the specific example of polyesters. So we have nylon, and nylon is a polyamide, and nylon is a copolymer of two different monomers. Like we have diamine, which is the first one, means that two different types of monomers attached in the nylon to form a copolymer. So this is the example of a copolymer, which we also talked about earlier. So in this copolymer, the two different molecules that are attached there, the first one is a diamine, and diamine means two amino groups are present in them. So we have, you can take this one as one amino group here, and plus in the center, this one which I left blank is, you can say that any number of carbon atoms can be attached there. So in the center, so we have this diamine. This diamine reacts with dicarboxylic acid, plus we have dicarboxylic acid, in which we have two carboxylic groups are present there, and here which I show you that this one we have so many different you can say that these are the simplified blocks. So each monomer consists of a chain of carbon atoms that are present in them. I'm just giving you here the general equation. This is not the specific one, so you can add any number of carbon atoms that are present between these one, and next carboxylic group is present like this one. So you can take n number of molecules of these diamines and dicarboxylic acid to form the nylon. So how nylon is produced? The first monomer and the second monomer, an amine group that contains NH2 on the first monomer reacts with the carboxylic acid which have COOH on the second monomer to make a link between the two molecules. So each time a link is made, a water molecule is lost. How a water molecule is lost? Like this one. Hydrogen from the amine group and hydroxyl from the carboxylic acid forms a water molecule which is H2O, and this is a byproduct, and then there is a link. Now nitrogen will make the bond with the carbon atoms, because carbon loses its one bond with the hydroxyl group and nitrogen loses its one bond with the hydrogen. So there is a space that is present between them. They join together and they form a link between. So this link that is formed here, this is the polyamide that is formed between them. As you can see here, polyamide form the reaction between the acid and the amine. So nylon, which is a specific polymer that is formed by the diamine and the dicarboxylic acid molecules that formed or that attach together and make a link, that is known as the polyamide. So after the reaction, what will happen, or after the removal of the water, we have here, you can see this one. If I tell you about the single one, like, so this is the polyamide, or you can see here, this is the polyamide or the amide linkage that is present in them, and the dotted line on the both sides, you can see here we have n number of molecules that are attached in this polyamide. So this is the formation of a polyamide or a nylon by the condensation polymerizations. What will happen? The hydrogen of this amine group will be removed with the hydroxyl of the hydroxyl group of the carboxylic acid, and then water is released and another carboxylic acid will attach there, and on the right side here hydroxyl group of carbon is removed and amine group will come, and diamine will give its hydrogen to form the water, and then we have so many molecules that are present on the left side and on the right side of this one. So this is how the condensation reaction happens. Because amide link or a peptide link is formed during the condensation polymerization, that's why it is known as polyamide. And why we call it as the polyamide? Because we know that the peptide linkage that is present in the proteins, that is also the carbon nitrogen one. The link between the carbon and nitrogen in the whenever amino acids attach together to form the proteins, that is also the peptide linkage or the polyamide. That's why we call it as. And the example of a polyester is PET, that's which we also discussed about. So that is the condensation reaction. Now we have the PET, which is the polyester, and condensation reactions happens in them also. And the polyesters are the condensation copolymers made from the two polymers, and one polymer is the hydroxyl group and the other polymer at each end, and this monomer is a diol, means two alcohol groups should be there, and the other monomer that we are using here, which is the carboxylic acid, which is COOH. So you have to take the dicarboxylic acid monomer and the diol just to make the polyester that we use in this one. So when the monomers react in condensation reaction, an ester link is formed with the water being lost at each time, and we have the ester link, that is the link when an ester is formed from the carboxylic acid, and alcohol that is also found in the polyesters, and in the esters they are present in the fats and also in the vegetable oil. So the example of this one is the reaction between them, and whenever they react together they form a polyester, or a, you can say that a polyamide is formed in them. So this is the formation of PET or a polyester by the condensation. Polyester is most common polyester polymer which is used in products all over the world. Like it can be found in the wide variety of packaging for both the food and drink, and also in the clothing fibers. Many PET produced globally is used for the in synthetic fibers, and with bottle production accounting for about 30% of the global demand. So this is about the polyesters. And next we have some also natural proteins. The above are the synthetic ones, and now we will talk about the natural polymers. And in the example of the natural polymers, the most common is the proteins that are formed by the monomers of the amino acids. All living organisms rely on the polymers for their existence, and these polymers are arranged from the very complex DNA that makes life itself possible to the more straightforward proteins and the carbohydrates that keep living things functioning. So our tissues and organs are made up of proteins, and in addition enzymes, which are also responsible for controlling the body's chemical reaction, they are also the proteins. And proteins are built up by the amino acids monomers. So we have different amino acids that attach together, like we have glycine, like maybe we have alanine, that have the amino acids. This is the peptide bond formation that happens between the two amino acids. You can see here this one, the R group, that refers to if the H is hydrogen is present there, that means we have glycine. And if in this R, or the you can say that the R represents that you can attach any molecule or substance here, like if CH3 methyl group is present there, that represents a specific one amino acid, that is alanine. So whenever amino acids react together, a water molecule is reduced, that is the byproduct you can see here, and then they form a linkage which is known as dipeptide bond that is present between the two amino acids. So on the left and on the right sides, monomers attach, amino acids are react together, and a amide linkage or a peptide linkage is present, and that is known as the dipeptide that forms here. Many short polymers up to the 15 amino acids are known as peptide, and longer chains are known as the polypeptides or the proteins. So this is how the proteins are formed by the reactions of the two different amino acids. Glycine and alanine are the simplest ones. So when they react together, the peptide linkage is formed just to produce a dipeptide between the two amino acids. So you can see here how the water molecule is released from these one. Hydrogen from the amine group of the amino acids, and hydroxyl from the carboxylic acid group that is present there. So this is how the natural polymerization occurs in our bodies. So now we will talk about the last content, which is related to the plastics. Plastics are the group of polymeric materials that are characterized by their plasticity, and the plasticity is basically, you can say that this is the ability. Plasticity is the ability to be molded or shaped under the pressure or the heat. So that's why the plastics are the materials that are molded into the different solid shapes. Their property makes plastics incredibly versatile. Many plastics have their advantageous properties. You can say that they are extremely strong but also low density, so are useful for the different products. So that's why we are using the plastics in the respirator mask. We have a prosthetic handmade from the recycled plastics by the 3D printing. So all these are the plastics. So the reuse, recycling, and if we talk about the disposal of the plastic waste is just, we can say that the plastic waste is a common sight all over the world today because of its use, right? So plastic products are light, cheap, and resistant to the corrosion. So characteristics have resulted in a significant rise in the use of the plastic over the 30 years. So the increased use means increased waste, and the problem with the plastic waste arises because they are not biodegradable. They are non-biodegradable substances. That's why the major reason happens just because of this one, biodegradable. Although the research is taking place to find microorganisms that break them into different parts, so not all the modern plastics are single used and go straight to the waste, but there are some that can be used to make the items like the soft drinks, bottles, and they can be reused and recycled again and again. like in so many different countries there are you can say that the reverse vending machines are there that are used to trade, and they are there just to trade used plastic bottles for the transit credits. So that is the major one, or you can say that this is the most important one for the reusing the different plastic. The reuse practices like these are not available or suitable for most of the plastic, but recycling is clearly preferable to disposal, both environmentally and also economically. So these are about the plastics, and next we have some environmental challenges related to the plastics. Like you can say that if we talk about the first, the use of plastic cause the disposal of them poses a number of environmental problems. So there is a need to adapt our use of these advantageous material in the following ways. So like the first one is reduce the level of plastic, and by reducing them, like reduce the level of plastic packaging wherever possible. You have to use some alternative for this one. So by reducing them, we can pose a number of environmental problems. So that is the major concern. And the second one, to avoid the use of single-use plastic. Avoid use of single use, that is also the major concern related to this one. And the subsequent littering with it, and to reuse and recycle wherever possible. This is the third one. We have to reuse and recycle wherever it is possible. Like I also told about the vending machines, the reverse vending machines that are there. So there are some alternatives to the recycling for the disposal, and those are included, but they have also detrimental effects. Like the first one is the incineration. Incineration is that can be used to burn the plastic waste, although care must be taken not to release the toxic fumes into the air, because whenever the incineration of PVC, polyvinyl chloride, for instance, can release the acidic fumes of hydrogen chloride. So if the open air burning of the plastic occurs at the low temperature, then it will release the toxic fumes that are toxic for the human health. And next is the disposal in the landfill sites. So if we dispose this one in the landfill sites, then we to suffer so many problems, because plastics are not biodegradable. So however, in these cases there is a problem of degradation of the products, and also the third one is by the accumulation in the oceans. Plastic pollution in oceans is a major problem that can be highlighted. So increased awareness of this problem has been a part of the background to drive the reduce of level, or you can say that the single-use plastics in our shopping and in packaging. So if we imagine the ocean wildlife and the seabirds that are harmed by the interaction with the waste plastic debris in our oceans, so that have highlighted the problem. The importance of the problem means that projects to collect the plastic waste from the oceans have been started in various regions. So when the high concentration of the items of the plastic bottles and the plastic bags can be found in the ocean, and much of the debris is actually small pieces of the floating particles not immediately visible to the naked eye, and this type of pollution arises in the form of microparticles. Microparticles, or you can say that the microplastics, the small pieces of plastics which are less than 5 millimeter in length, that enter the natural ecosystem from a variety of sources, including the cosmetics, clothing, and industrial processes. So microbeads and all these are the different types of the microplastics. And these microplastics or small pieces of plastic in the ocean arise from the breakup of the larger objects by the oceans themselves, but much of them originate from the processes in the plastic industries. So we have so many different microplastics. This one is the magnified view of the microplastic, or you can say that the like plastic beads or something, anything that is found on a beach. And here you can see this one, the microscopic view of this one, like that maybe these microbeads may be from the cosmetics or something else like that. So the plastic pellets or any type of resin materials which are under 5 millimeter in diameter, they serve as a raw material in the production of the plastic products, and these small plastic beads or plastic objects find their way to coastal waterways and also the oceans. So microbeads or the microplastics are much that smaller plastic spheres, less than, you can say that, the 1 millimeter in diameter, and they are found in the cosmetic, facial scrubs, shower gels, and also in the toothpaste. So that's why the use and misuse of the particle plastics is a major environmental issue. So we should reuse and recycle all these plastics. And plastics are made from the synthetic polymers, and the properties of the plastic raise problems for their disposal. So there are environmental challenges that are posed by the disposal of the plastics in landfills, toxic fumes from the incineration, and the accumulation of the plastic debris in the oceans also. So this is all about today related to the chapter number 20, which is the petrochemicals and also the polymers. Hope you understand all. If you have any question, you can ask in the comment box. Please, if you like our content, then please subscribe our channel and share with others too. So this is all about today. We will meet in the next video.